Good morning, everyone. Welcome to One Concept Per Day portal. And this is your question number 3. And the concept that we are learning now is about free body diagrams. And in the first question, we had learned something about how to use free body diagrams in case of rotation. Okay, so which was taken from question paper May 2006. So what is a translational equilibrium? What is a rotational equilibrium? And how do you arrive at determining the normal forces? The second problem represented about the tension forces acting on the balloon which is being tied to it, and how to find out the tension force. And then we also looked at how do you do the resolution and so on. And then we also looked at what is the speed or what is the acceleration of the balloon when the balloon is being released from rest. And then what happens to during the time of acceleration, so what exactly happens to the balloon, and how does the velocity vary, and what happens to the air resistance. So this is what we have learned in the previous example. Now the next question is about mechanical power. Okay, so this is a little bit different from FBDs, but anyway, so I thought this would also be a question related to FBD and especially related to mechanics, so I have put this on here. Okay, so define power. How do you define power? Power is nothing but energy divided by time, or maybe you can say work done divided by time. The actual way to define a power is nothing but the rate of doing work. Rate of doing work is power. Rate of doing work is power. Okay, next. A car is traveling with a constant speed v along a straight horizontal road. Okay, car is traveling with this way. There is a total resistive force F acting on the car. So there is a total resistive force F acting on the car. Deduce the power P to overcome the force F is P is equal to F into V. So that's what is happening. It says the car is traveling with a constant speed V, which means what? There is already a force given by the car over here. There's a force given by the car over here. So let me say this is F2 over here. Now at the same time what's happening is, okay, there's a resistive force acting over here. How could the resistive force act? It could be maybe due to the friction over here. Maybe due to the friction. I was asking you what is the power P to overcome the force F. So we know that the work done in moving the car from one end to other end, let us say it has traveled a distance S here, is given by the car is given by F2 times S. F2 times S. Okay. And therefore, if I ask you what is the power there, power of the car to travel this distance, then I can now write this as W by T is equal to power, which should be equal to F2 into S divided by T, right? F2 S by T, or I've grouped them together. One step I have skipped over here. And write this F2 into F, F2 into V. But here he has asked you what F2 in F into V, not F2 into V. So what is F2 here? But we know if at all if the car is moving with uniform velocity, then this force should be equal to this force, right? Only the net force acting on the object is 0, and hence the car will be moving either with uniform velocity or it would be at rest. If it already had an inertial direction, inertia of motion, so therefore, so F2 should be equal to F. So I can now write this as F into V. Thus we have proved that P is equal to F into V. Okay, now let us move on to the next question. The car drives up a straight incline. The total height of the incline is 0.3 kilometer. Okay, so this height is 0.3 kilometer. This incline length is 4.8 kilometer. Then the car moves up the incline at a steady speed of 16 meters per second. See, whenever something is steady speed, which means what? Definitely the upward force should be equal to downward force, right? During the climb, the average resistive force on the car is 5 into 10 square Newton. The total weight of the car on the driver is 1.2 into 10 power 4 Newton. Determine the time it takes for the car to travel from the bottom to the top of the incline. He is asking you what is the time taken to start from here and to reach this point. Start from here and to reach that point. So how do you do? Very simple. So what does it say? It moves with uniform velocity. Okay. Do not consider about what is the resistive force, what is the gravitational component. Nothing you need to consider, because if it is moving with uniform velocity, you know what is the distance over here, and he has already given you the velocity also, which is 16 meters per second. How do you find time? Time is equal to distance by velocity. Why? How did I get this? I got this from V is equal to T by T, right? V equal to T by T. See, if at all, if there was an acceleration and deceleration, then you should not use this, right? You will not use this. But since there is nothing like that over here, he automatically he says that though there is a resistive force acting, there is a force acting due to thrust of the engine, everything is in there, but they cancel each other. We are not bothered about what is happening over there. We will only say the net force acting on the car is 0, and as a result of it, the car is moving with uniform velocity. The moment you say it's moving with uniform speed or velocity, you can just use this equation. So therefore, let us use T equal to d by V. We will use T is equal to d by V. What is the d over here? D is 4.8 kilometers. So I take 4.8 into 10 cube divided by 16 meter per second. 16 meter per second. So you will get the answer in terms of seconds. So let us do this also, which should be, I pull my calculator a little bit here. Right. So this should be 4.8 by 16, right? Okay. 4.8 divided by 16. When I do this, I get 0.3 over here. 0.3 multiplied by 10 cube. How much will this be? This will be 300 seconds. The time taken for it to travel from the bottom to the top of the incline would be 300 seconds. Okay, next question. Determine the work done against the gravitational force in traveling from the bottom to the top of the incline. So what is it you need to find? Work done against the gravitational force. What is that value? Always understand whenever this question is being asked, work done against the gravitational force. The answer here is nothing but mgh, okay, which is nothing but your gravitational potential energy. You need to do an extra work equal to mgh in lifting an object from the ground to a second, right? So therefore, it should be equal to mgh. Now, what is that value of w equal to mgh? Now, what we do is let us go for mgh. Is the value of m given to you? Value of total weight of the car is given. See, this is total weight of the car. Okay, it is not m here. What is it given here? See, this unit is Newton, so you should be very careful while doing such problems. This should be mg is given to you. Okay, it's not m here. So therefore, here I can now write this as 1.2 into 10 to the power of 4 Newton. The value of mg is given. And what is the height through which it's been lifted upwards? It is being lifted upwards by 0.3 kilometers. Okay, I'll write this as 0.3 kilometers. It's always good to write down the unit along with it. Okay, to understand the conversion, which should be 1.2 into 10 to the power of 4 multiplied by 0.3 into 10 cube. Now let us do this calculation to understand what is it I get here. This should now be equal to 1.2 multiplied by 0.3. I get 0.36. 0.36 multiplied by 4 plus 3 7. 10 to the power of 7, or maybe I will write this as 3.6 into 10 to the power of 6 joules. This is the answer for the first one. Okay, let us move on to the next one. Using your answers to 1 and 2, calculate a value for the minimum power output of the car engine needed to move the car from the bottom to the top of the incline. Now, from the bottom to the top of the incline, you need to move the car from here. Can't you apply only this much energy? No. What is the reason? Because if you apply this much amount of energy, we assume that the object is being lifted from here to here, right, to same height. But what's happening here? The car has to move on this road, and there is a resistive force acting over here. It has to overcome the resistive force and also overcome the gravity. See, in one way, gravity is also acting like a resistance for it, because you have to move away from the earth. Earth is always trying to pull it, right? So therefore, gravity is acting. In addition to this, there is a frictional force also. So therefore, now what is the value of the minimum output power you need? Okay, the minimum output power. So if you want to calculate the output power, what we'll do is we'll first find out the energy here. The energy here is nothing but you should apply a force F multiplied by D. What is F here? The applied force multiplied by this distance. This distance you have to cover this distance constantly. You have to apply it so that okay, you will be able to cover it. Plus, you have to also overcome the gravitational force. If this plane was not there like this, if it was not an inclined plane, I mean it was like this over here, you just need to have F into D only. You need not have this one here. Since it has been inclined, so definitely you need to apply this also, which should be equal to this W. Which is this W? This value. Okay. So therefore, now let us substitute the value. What is the value of F? Okay. Is the value of F given to us? Now it says the car moves up the incline at a steady speed of 16 meters per second. Very similar to the previous problem. Okay. The previous problem also I said that there is a resistive force. There is a resistive force and there is an applied force over here. Okay. So in the F applied is equal to F resistive, the car will definitely move with a uniform velocity. So therefore, the resistive force is already given. That means applied force is also equal to the same force. What is the force here? This is the force acting here, right? So therefore 5 into 10 square, 5 into 10 square is the applied force. 5 into 10 square multiplied by what is the distance traveled? Distance traveled is 4.8 kilometer along the incline. 4.8 kilometer plus this value 3.6 into 10 to the power of 6. When I do this, how much do I get? 5 8s are 40, 5 4s are 20, 24. So we get 24.0 multiplied by 10 to the power of 2 plus 3 is 5 plus 3.6 into 10 to the power of 6, which I can now write this as, this is 24 into 10 to the power 5, right? I can now write this as 2.4 into 10 to the power of 6 plus 3.6 into 10 to the power of 6. When I add these two, what do I get here? 2.4 plus 3.6, 3.6, 4 plus 2, 6. 6 into 10 to the power of 6 joules. This is the amount of energy that you need for the car to start from here and to go there. Now what is being asked over here? Minimum output power is asking you. Energy is not sufficient. I want the power here. How do I calculate the power? Energy divided by time. Okay. I have to take this energy divided by time. Now what is the time given here? Is the value of time given? Let us find out. Is the time given? We calculate the time here. It is 300 seconds. We take up this time. We'll write 6 into 10 to the power of 6 divided by 300. How much is it? 3 ones are, 3 twos are. Should be 2 into 10 power 6. There were double zero. There was 100 here. So this will be minus 2 over here. It should be 2 into 10 to the power of 4. What is the unit for power? Watt. Right? So 2 into 10 power 4 watt, or this should now be equal to 20 kilowatt. This should be your answer. Okay? Now let us move on to the next question. From the top of the incline, the road continues downwards in a straight line. At the point where the incline starts to go downwards, so now we have already climbed upwards like this. We already climbed upward like this. Okay. Now what? Now the car is here. Now the car is here. Now the car is now climbing downwards. At the point where the incline to go downwards, the driver of the car in C stops the car to look at the view. In continuing his journey, driver decides to save the fuel. Okay, anyway it is down, right? So I would like to save the fuel. So then he switches off the engine. Okay, anyway gravity will put him, so he just puts it off. The car descends a height of 0.3 kilometer, the same height, in a distance of 6.4 kilometer before leveling out. Okay, so it has to descend it like this. The average resistive force acting on the car once again is 5 into 10 square newton. Now as the car is coming downward like this over here, the resistive force is 5 into 10 square newton. Okay, estimate the acceleration of the car down the incline. Now earlier I took this as uniform velocity. Now I am taking this as acceleration. Okay, let us understand what's happening over here. So towards it. Now how do I start with this? So what we do is, let us draw the free body diagram. This is where free body diagram comes into play. The free body diagram tells you this is the mass of the car. Okay, m into g will be the weight of the car over here. So I do not know what is this angle. Let me keep this angle theta over here. Right? Keep this angle theta over here. So therefore, if this is theta, then if I drop this line like this over here, this angle will be 90 minus theta. Right? And if I draw the normal here, what do I get over here? This is my normal force. So the force mg acting along this direction would be mg cos 90 minus theta, which will be equal to mg sin theta. I still do not know what's the value of theta, and this value is mg cos theta. It's also known to me. Okay. Now what is he asked? So we need to find out the free body diagram. There is a resistive force acting here. Let me call this F. Those values known to you. Since you say it is accelerating, okay, so what I do is, I'll write down the force equation. I'll write mg sin theta. Why mg sin theta? Because this is the force and the object is moving in this direction. So I consider this as my positive force, and this should be my negative force, minus the value of F. I'm not substituting this, which should now be equal to mass of the car multiplied by acceleration. I return all this. And then what do I have here? So I have mg. What is the value of mg? Mg value is already known to me. Okay, somewhere it was given. We found out this value mg here, right? Which is 1.2 into 10 power 4. I'll take that value. And I'll substitute it here. 1.2 into 10 to the power of 4 into sin theta. What's the value of sin theta? I'm not aware of sin theta, but I can determine from here. See, I can determine from here saying that sin theta is equal to opposite side by hypotenuse. What is this now? Opposite side is 0.3 kilometer divided by what is hypotenuse? 6.4 kilometer. Kilometer goes away. So I get this answer as, let me take up my calculator and do it, 0.3 divided by 6.4. I get the answer 0.046875. I don't want this much. I'll take 0.047. 0.047. I'll take this value. Okay, so I'll write this as 0.047 minus, what is the value of F? Resistive force is 5 into 10 square. I'll write this also. 5 into 10 square is equal to, what is the value of M? I do not know the value of M, but unfortunately I know M into G is equal to 1.2 into 10 to the power of 4. 10 to the power of 4. So therefore the value of M should be 1.2 into 10 to the power of 4 divided by 9.8. Okay. So therefore I will substitute this value. I'll take up this value. It's better to calculate this. 1.2 divided by 9.8, which should now be 0.122. 0.122 into 10 to the power of 4. Okay. So I'll write 0.122 into 10 to the power of 4 into, see, all the values are known except the value of E. I can easily find this. Now let us calculate this using my calculator. What do I get here? I get this as 1.2 multiplied by 0.047. I get this as 0.0564 into 10 power 4. Let us see whether 10 power 4 is common. It's not common. Okay. Now what I will do is 10 square is common. I will multiply this by 100. Okay, or maybe I'll just write it down, not to avoid this one. So avoid confusion, we will just write out the value 0.0564. I'll write it as 0.0564 into 10 power 4 minus 5 into 10 square is equal to 0.122 into 10 to the power of 4 A over B. I'll write like this also. Then what I will do is I'll divide this by 10 square everywhere. Okay. So what do I get if I divide by 10 square? I get 0.0564. Okay, anyway you have a calculator, right? Why should I do all this? You can directly do this. So when I do this, I get this value as 564 minus 500. You can do it by calculator. This should be equal to 1220 A. Okay, or your A should be equal to 64 divided by 1220. Do I get the same answer? 62.5 divided by 1.2 into 10 to the. That's right. Okay, so therefore I'll do this 64 divided by 1220. I get the answer as, I'm sorry, I made a mistake here. 64 divided by 1220 will give me 0.0524. 0.052 meter per second. 0.052 meter per second square. That's right. So I get the answer as 5.2 into 10 to the power of 1, 2 minus 2 meter per second. Okay. This is the acceleration of the car down the incline. Right. Now let us move on to the next one. The speed of the car at the bottom of the incline. Okay, which means what? Now the car started here, you switch off the engine at this point, and as it comes down, definitely its speed is increasing. Why is it increasing? The reason is because there is an acceleration here. Definitely when it comes here, it has some higher speed. Let us find out what is the value of the speed. How do you find the value of the speed? You can use your equation of motion, which is v square equal to u square plus 2as, right? So now u square is 0 plus 2 into, what's the value of a? I got this value, 2 into 0.052 multiplied by, what's the value of s over here? Value of s is 6.4 kilometer. 6.4 kilometer, which should now be, now let us calculate this value once again. I get this as 2 into 0.052 multiplied by 6.4 is 0.6656. 0.6656 into 10 cube. It should now be, it's 1000 multiplied, right? Because we have 10 cube here. So it should be 1, 2, 3, 665 or 666. 666 meter, 666 you get out here. This is your v square. I do not consider this value directly here. So v is equal to square root of 666. I want to calculate this. How much will I get it? It should be 25.8. Okay. Now let me write it down here. This should be equal to 25.8 meter per second. So you can answer, you can either get an answer of 25 or 26 meter per second. This is right. Okay. Now, in fact, for the last few hundred meters of its journey down the incline, the car travels at a constant speed. State the value of the frictional force acting on the car while it is moving at a constant speed. He says not only that, okay, the velocity is seen to be a constant throughout the incline. Throughout the incline, it is not increasing. Okay, but at some point of the path, okay, somewhere let us say it has not reached the bottom here. At this point itself, I found from here to here, few hundreds of meters are there. I find that the velocity here is seen to be a constant. Okay, so determine what is the frictional force at this point. Now the question is, okay, nothing else is given to you. Using this, how you need to find out. What you do is, if the velocity here is constant, let us look at this here. If the velocity here is constant, what should be the case? See, there is a gravitational force which is acting it downward like this. There is a resistive force which is acting it like this. Now, why was the velocity not a constant in this complete path? Why only so special over here? The reason could be because the gravitational force was larger than the frictional force. Okay, that's what was happening. Now, when it came here, maybe it has reached that particular velocity, which is very, very high velocity. So 25 meter per second is not a smaller velocity. Definitely, it's a high velocity. So therefore, if it is a high velocity, there is a possibility that the friction or the air resistance would have acted more onto it. Okay, and as a result of this, the velocity may not have increased. Theoretically, it could be the correct answer. Maybe possibly at this point, this could have been even not even 25 theoretically, but experimentally, you would have found that this could be around 22 meter per second, and throughout its path, it is 22 meter per second only. Okay, so how did I get this one here? Because I assume that the acceleration never becomes zero here. What was the value of acceleration earlier? 0.052 meter per second square was the acceleration, and I assume that throughout its path, the acceleration is remaining the same. But maybe who knows, the friction was so high, there was a huge air resistance, because you move faster and faster, the wind would be also moving to you in a much larger speed, so air resistance would have been higher, so which might have made the total force, negative force, total force which was acting here would have been equal to this one. Okay, what did I say? The total force acting upward, that is a resistive force would have been equal to the applied force. What was the applied force? The gravitational force, right? So therefore, now if I am asking you what is the value of the frictional force, what is it I am asking here? I am asking you to find out this value here. Now I already said that if velocity has to be a constant, as given here, you should have F resistance should be equal to Fg. That's the answer for it. What is the value of Fg? Let me go back here. See, what is the value of Fg? Fg is nothing but mg sine theta, right? The component of mg sine theta was acting over here. Mg sine theta was acting over here. That is your Fg. So what was that value? The value of this one was seen to be 564 Newton. This I am not considering because it's a resistive force. It is already given to you. So therefore, your resistive force in that case, F resistive force should have been equal to 564 Newton. This should be your answer. Say the value of the frictional force acting on the car while it is moving at constant speed. Okay, which is equal to 564 Newton. So this is your answer. Okay. Thank you.